Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the frequency polygon practice questions. So if you need any extra help on drawing frequency polygons or interpreting frequency polygons, if you go to corbettmaths.com/contents and you scroll down to videos 155 and 156, one of those will show you how to draw a frequency polygon and the other one will show you how to interpret or read frequency polygons. But in this video, we're going to look at the video solutions to the frequency polygons practice questions. So let's get started. Okay, question number one. So question number one says the table gives information about the time taken in seconds for students to complete a puzzle. So 7 of the students take between 0 and 10 seconds, 25 between 10 and 20, 38 between 20 and 30, 16 between 30 and 40, and 12 between 40 and 50. And we've been asked to draw a frequency polygon to show the information in the table. So what we're going to do is we're going to plot these frequencies at the midpoint of each of these categories. So we're going to go 5 across and 7 up, 15 across and 25 up, 25 across and 38 up, 35 across and 16 up, and 45 across and 12 up. And then what we're going to do is we're going to plot those points and we're going to join them up. Okay, so let's do that. So we're going to go 5 across and 7 up. So 5 across is going to be here. And in terms of 7 up, we're going from 0 to 10, and it's 10 little boxes. So each one of these little boxes is worth 1. So we're going to go 5 across and we're going to go up to 5, 6, 7. So we'll just put a little cross there. So that's 5 across and 7 up. Okay, next point. Our next point is 15 across and 25 up. So 15 across and 25 up will be there. So 15 across and 25 up. Next is 25 across and 38 up. So 25 across and 38 up. So 25 across, 38 up will be 2 below 40. So there. Next, 35 across and 16 up. So 35 across and 16 up. So 15's here. So one more, 16's there. And finally, 45 across and 12 up. So 45 across and 12 up. So 5, 10, and then 12 will be there. Okay, so we've drawn our 5 points. Now what we're going to do is we're going to get a ruler and we're going to join them up. A ruler and pencil, and we'll join them up. So we'll look something like this. So we'll join up our first point to our second point, our second point to our third point, our third point to our fourth point, and our fourth point to our fifth point. And that's it, we've drawn our frequency polygon. Don't join up anymore, don't join the first to the last, for instance. So it's just the first to second, second to third, third to fourth, and fourth to fifth, like so. So that's our frequency polygon, and that's it. Okay, let's have a look at our next question. Okay, let's have a look at question number 2. So question number 2 says the table gives information about the distances thrown in meters at a school sports day. So we've got between 0 and 2 meters, 5 people threw that. Between 2 and 4, 10 were thrown between 2 and 4. Between 4 and 6, 21. Between 6 and 8, 18. And between 8 and 10 meters, 1 attempt was thrown between that distance. And we've been asked to draw a frequency polygon for the information in the table. So again, we're going to plot the frequencies at the midpoint of each category. So between 0 and 2 will be 1, between 2 and 4 would be 3, between 4 and 6 would be 5, between 6 and 8 would be 7, and between 8 and 10 would be 9. So we're going to go 1 across and 5 up, 3 across and 10 up, 5 across and 21 up, 7 across and 18 up, and 9 across and 1 up. So let's do that. So the first one, 1 across and 5 up. So 1 across and 5 up would be there. Next, 3 across and 10 up. So 3 across and 10 up would be there. Next would be 5 across and 21 up. So 5 across would be here, and 21 up. Now we need to make sure we know what these little boxes are worth. So we've gone from 0 to 5 in 10 boxes. Now if we do 5 divided by 10, that's 0.5. So that means that each little box is a half. So it'd be like a half 1, 1 and a half 2, 2 and a half 3, 3 and a half 4, 4 and a half 5. So that means that each time we've got 2 boxes, we're going up 1. So that's 1, up another 2, 2, up another 2, 3, up another 2, 4, up another 2, 5. So whenever we want to go 5 across and 21 up, we're going to go up to 20. And then we're going to go up 2 little boxes to 21, because each of the little boxes is worth a half. So that'll be 21 there, which is 2 little boxes. So we've gone 5 across and 21 up. And next, 7 across and 18 up. So 7 across would be there, and 18 up. Let's go up to 15. Got 2 boxes would be 16, up another 2 boxes, 17, up another 2 boxes would be then 18. So there, that's going to be our 7 across and 18 up. And actually another way to consider it is in between 15 and 20 would be 17 and a half. So going up another half would be then 18, which is there. And finally, we had 9 across and 1 up. So 9 across would be here, and 1 up would be 2 little boxes, so it would be there. Okay, and then let's join our points up with a ruler and a pencil. So get our ruler and pencil and join up the first point to the second point, the second point to the third point, the third point to the fourth point, and the fourth point to the last point, like so. And that's our frequency polygon. Okay, let's have a look at our next question. Okay, let's have a look at question number 3. So question number 3 says the table gives information about the income of 200 households in a village. So 40 households have an income between 0 and £20,000. 75 households have an income between £20,000 and £40,000. 64 households have an income between £40,000 and £60,000. 20 households have an income of between £60,000 and £80,000, and 1 household has an income between £80,000 and £100,000. And we've been asked to draw a frequency polygon to show that information. So we're going to go to the midpoint, so that's going to be 10,000 and up 40, 30,000 and then up to 75, 50,000 and up to 64, 70,000 and up to 20, and 90,000 and up to 1. So let's start off with our first one, going 10 across, 10,000 across and up to 40. So if we go to 10,000 across and up to 40, that would be there. And actually, just before we carry on, let's make sure we know what the scale is. We're going from 0 up to 20, and there's 10 little boxes, and 20 divided by 10 is 2. So that means we must be going up in 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Fantastic. Okay, so we've done our first point, which was 10 across 40 up, and our scale obviously is in thousands here. Next, we want to go 30,000 across and up to 75. So we're going to go 30,000 across and up to 75. So going to 30,000 would be here, 30,000, and then up to 75, well, 60, 70. Now each of the little boxes is worth 2, so it's going to be 72, 74, and 75 would be in the middle here. So that's 75 there in the middle. Okay. Our next point would be 50 across and 64 up. So 50,000 across and 64 up. So we want to go up to 64. So we're at 60. 62, 64 would be here. Okay, next we're going to go in between 60,000 and 80,000. That's going to be 70,000 across and 20 up. So we're going to go to 70,000 and 20 up, which would be here. And finally, our last point is between 80 and 100, so that's going to be 90, and we're going to go up to 1. So we're going to go 90,000 across, and each box is worth 2, so we're going to go up half a box. We're just going up to half there, so just there. And then we're going to get a ruler and pencil. We're going to join those up. So we're going to go from here to here, from here to here, from there to there, and finally from there to there. And that's it. We've drawn our frequency polygon. Okay, let's have a look at our next question. Okay, question number 4. Question number 4 says the table shows information about the time taken for teachers to travel to work. So we've got the time taken in minutes. So 10 teachers take between 0 and 10 minutes, 28 teachers take between 10 and 20, 46 between 20 and 30, and so on. And we've been asked to draw a frequency polygon to show this information. Now, if we have a look at our frequency polygon, we don't have a scale here. So let's put our time along the horizontal axis, so time down here. And we're going from 0 minutes up to 50 minutes. So we're going from 0 up to 50. So, and 50 minutes. And vertically, let's look at our scale. So we need to go up to highest frequency of 46. So let's have a look at our vertical scale. And let's write frequency. So frequency. And if we look at our highest frequency is 46. So we want to go up to 46. So let's go start at 0. And let's see if we can go up in 10. So 10, 20, 30, 40, 50. Fantastic. So we can go up in 10s here. So 10. So we've labelled our axes. Now we just need to plot our points. So our first one is in between 0 and 10 minutes. So we're going to go to 5 minutes and we're going to go up to 10 as a frequency. So let's go to 5 minutes and up to 10. So that'll be our first point. Next, we've got between 10 and 20 minutes, and that's 28. So it's going to be 15 minutes and up to 28. So let's go to 15 minutes and up to 28. Now we are going up in ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going 15 and up to 28. So 20, 25, 26, 27, 28. So that will be there. Okay, let's have a look at our next point. So our next point is in between 20 and 30. So we're going to go 25 across and we're going to go up to 46. So let's go to 25 across. So 25 across would be here. We want to go up to 46. So there's 40, 45, 46 would be there. Our next point is between 30 and 40 minutes. So we're going to go to 35 and up to 23. So 35 and up to 23, 21, 22, 23 would be there. And then finally, we've got between 40 and 50 minutes. So we're going to go 45 minutes and up to 12. So 45 minutes and up to 12. So 10, 11, 12. So that would be there. Now we're just going to get a ruler and pencil and join those points up. So we'll get our ruler and pencil. And we'll join up the first point to the second to the third to the fourth, and the fourth to the fifth. And that's it. So we've drawn our frequency polygon, and that's it. Okay, let's have a look at our next question. So question number 5. Question number 5 says the table shows information about the length of 60 spiders. So we've got the length between 0 and 0.5 centimeters, there's 8 spiders. Between 0.5 and 1 centimeter, there's 17 spiders. Between 1 and 1.5 centimeters, there's 20 spiders. Between 1.5 and 2 centimeters is 10 spiders. And between 2 and 2.5 centimeters, there's 5 spiders. And we've been asked to draw a frequency polygon for this information. So along the horizontal axis, we're going to have the length, and that's going to go from 0 to 2.5. And for the frequencies, we're going to want to make sure we can go up to at least 20 for our frequency, and that's going to be our vertical axis. So let's label those. So in terms of our lengths, we want to go up to 2.5 centimeters. So let's do 0. Let's try 0.5, and then 1, and 1.5, and 2, and 2.5. Fantastic. And vertically, we want to go up to 20. So let's go 0, and then let's do 5, 10, 15, 20. And then that's our vertical and our horizontal axes labeled. So we've got our frequencies vertically and our length horizontally. So our first point, we want to go in between 0 and 0.5. So the midpoint of 0 and 0.5 would be 0.25 and a frequency of 8. So we're going to go to 0.25. Now what's quite nice is because we've got 0 and 0.5 in the middle is this, and you can see it's a slightly thicker grey line. So you can see it's going to be along that line, and it's got a frequency of 8. So we want to go up to 8. Now let's make sure we know what the scale is vertically. We go from 0 up to 5. So we're not going up in ones. It's not 1, 2, 3, 4, 5, 6, 7, 8. It's not going up in ones. So let's try 2 boxes for 1. So 1, 2, 3, 4, 5. Yeah, we're going up in 0.5s. So we want to go up to 8. So we're going from 0.25. So here, and we're going to go up to 8. So in the middle here would be 7.5, and up another one would be then 8. Or another way to do it is to go for 5 and then go up 2 boxes, 6, go up 2 boxes, 7, and up 2 boxes, 8. So that would be there. Our next point is between 0.5 and 1. So it's going to be 0.75 and up to 17. So 0.75, again, it's a slightly thicker line, so that's great. And up to 17, so 15. Go 2 boxes as 1, so that's 16. And then another 2 boxes, 17, so that's going to be there. Our next point is going to be in between 1 and 1.5, so that's going to be 1.25 and up to 20. So 1.25 will be here, and up to 20 would be there. Next, we have got 1.25 and 2, so in the middle of those would be 1.75 and up to 10. So again, between 1.5 and 2, that's that thicker line, and up to 10 would be there. And finally, our last point in between 2 and 2.5 would be 2.25 and up to 5. So 2.25 would be in the middle there, and up to 5 would be there. And we'll just get a ruler and pencil and join those points up. So ruler and pencil, and let's join those points up. So the first to the second to the third to the fourth, and the fourth to the fifth. And that's it. So we have drawn our frequency polygon. Okay, let's have a look at our next question. So question number 6. Question number 6 says the frequency polygon shows the time taken for 100 students in Class A to solve a maths question. And if we look at our frequency polygon, it's got 1, 2, 3, 4 points. And the first point is in between 0 and 10 seconds. And 5 students have taken in between 0 and 10 seconds there because it goes up to 5. Our next point is here. So that's between 10 and 20 seconds. And 40 students have taken between 10 and 20 seconds. So our next point is in between 20 and 30 seconds, and we've got 45 students have taken between 20 and 30 seconds. And finally, our last point, it's in between 30 and 40, and it has a frequency of 10, so that means that 10 students have taken between 30 and 40 seconds. And if we go on down, we've then got the table shows the time taken for 100 students in Class B to solve the same question. Draw a frequency polygon to show the information on the diagram above. So we need to show this information on the frequency polygon above. So we've got between 0 and 10 seconds, 2 students took that amount of time. So if we have a look here, we're going up from 0 to 10, and each box is going to be worth 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each little box is worth 1. And we've got between 0 and 10 seconds, that's going to be plotted at 5, and it's got a frequency of 2. So that's going to be our first point. Next, between 10 seconds and 20 seconds, 33 people took that amount of time. So between 10 and 20 seconds, we're going to plot that at 15. We're going to go up to 33. So 30, 31, 32, 33. That will be there. Our next one is between 20 and 30. So it's going to be 25 seconds. And we're going to go up to 42 as our frequency. So we're going to go between 20 and 30. So it's 25 and up to 42, which would be here. Next, we've got between 30 and 40 seconds. So we're going to plot it at 35 and we're going to go up to 14. So we're going to go to 35 and up to 14. So 10, 15, so down 1, 14. And finally, our last point is between 40 and 50 seconds. We're plotted at 45 seconds and we want to go up to 9. So we're going to go to 45 seconds and up to 9, which should be here. Then we're going to get a ruler and pencil and join those up. So ruler and pencil and join those points up. The first to the second to the third to the fourth, and the fourth to the fifth. And that's our second frequency polygon. Okay, let's have a look at our next question. Part B says, compare the times taken by the students in Class A and Class B. So we've been asked to compare the times by the students in Class A and Class B. So let's look at our frequency polygons and let's actually label which one's which. So the first one, the one that was drawn for us, is Class A, so that's that one, and the one beneath it here is Class B. Okay, and if we have a look at them, the Class A one, well, as you can see, it's slightly more over to the left. You can see that we've got more people between 0 and 10 seconds, more people between 10 and 20 seconds, more people between 20 and 30 seconds, and then actually it's got slightly less between 30 and 40, and actually there's no people in Class A that took between 40 and 50 seconds. So I would say Class A, the time's actually slightly further to the left. So that means that they answered the question in a quicker time, so it took them less time to answer the question. Whereas Class B, fewer people were able to answer the questions in a quick time, and actually some of them even took longer than 40 seconds. So what I've written here is I've said that Class A completed the question in a shorter time as their distribution, or their frequency polygon, is more to the left, it's closer to 0. And some students in Class B took longer than 40 seconds. So that's what I've written. Okay, let's look at our next question. Okay, question number 7. So question number 7 says, the table shows the distance travelled to school by 48 students. And the question says, draw a frequency polygon to represent that data. So let's draw a frequency polygon. So we've got between 0 and 2 miles. So we're going to go 1 across and 20 up. So let's go 1 across and 20 up. So 1 across would be here and up to 20. So we're going to go up to 20. So that's going to be the point there. Next is between 2 and 4. So it's going to be 3 across and 10 up. So 3 across and 10 up will be there. Our next point between 4 and 6, that's 5 across and 11 up. So 5 across and 11 up. So now here, because we've got 0 and 2, in the middle would be 1. So we've got 0 and then 2, 4, 6, 8 and so on. If we wanted 1, it would be in the middle. If we wanted 3, it would be in the middle and so on. Now we're going 5 across and we're going 11 up. So it's going to be in between 10 and 12. So it's going to be in the middle here. So that would be there. And then next we're going to go between 6 and 8. So we're going to go 7 across and 4 up. So 7 across and 4 up. There. And finally, we've got between 8 and 10, so that's 9 across and 3 up. So we're going to go 9 across and 3 up, which will be there. And we just need to join our points up. So we're getting a ruler and a pencil, join up the first to the second to the third to the fourth, and the fourth to the fifth. And that's it. So we've drawn our frequency polygon. So part B says a student is chosen at random. So one of the 48 students is chosen at random. So it's out of 48 because we said a student is chosen at random. And we're asked to work out the probability that this student travels more than 6 miles to school. So we need to figure out how many students travel more than 6 miles to school. Now we could look at the frequency polygon. I like to look at the table for this. So did those students travel more than 6 miles? No, they didn't. They traveled between 0 and 2. Between 2 and 4? No, they don't travel more than 6 miles. Between 4 and 6, well, it's 4 up to and including 6 miles. Now the question says probably that they travelled more than 6 miles, so they didn't travel more than 6 miles. Now these 4 students, they did travel more than 6 miles because the distance they travelled is greater than 6 but less than or equal to 8 miles. So those 4 would work. And these 3 students, they've travelled more than 8 miles but less than or equal to 10. So those 3 students as well would travel more than 6 miles. So altogether, 7 students, 4 plus 3, is equal to 7. So 7 students travelled more than 6 miles. So that means that it's 7 out of 48. If we picked one of the students at random, there's 48 of them, and 7 of them travelled more than 6 miles, so the probability would be 7/48. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at question number 8. So question number 8 says the table shows the speeds of cars travelling through a village. So we've got the speeds between 0 and 10, 10 and 20, 20 and 30, 30 and 40, 40 and 50, and we've got the frequencies. And part A says find the class interval that contains the median. So in other words, if we've got all the speeds and we arrange them in order and find the median, would the median be in this category? Would it be in here? Would it be in here? Would it be in here? Or would it be in here? Now, there's two different ways to approach this question. Because it's group data, we don't actually know the speeds. We don't know the speeds of these 6 cars. We don't know the speeds of these 22 cars and so on. So there's two different ways we can approach this. The first way is this, okay? You can add up the frequencies to see how many cars there are all together. So 6 plus 22 plus 90 plus 80 plus 42. And it's a calculator question. That's equal to 240. And you can say, well, there's 240 cars. Let's find the position of the median. So for instance, if we had 5 numbers, just say they were 7, 8, 10, 12, and 20. And if we had 5 numbers and we wanted to find the position of the median, we could take our 5 numbers, we could add 1, that would be 6, and we could do 6 divided by 2. And 6 divided by 2 is equal to 3, so it's the third number. So we could do n plus 1 divided by 2. And there's 1, 2, 3, 4, 5 numbers. If you add 1, that's 6 divided by 2 is the third number. So that's the position of the median. So let's find, here we've got 240 cars, so we've got 240. We can then add 1, which is 241. We can then do 241 divided by 2, and that's equal to 120.5. So we're looking for the 120.5th car. So let's go down and see where, if we arrange these in order, so we arrange these 6 speeds, and then these 22 speeds, and these 90 speeds, and these 80 speeds, and so on, which of these categories would the 120.5th value be in? So would the 120.5th value be in here? No, there's only 6 cars so far, so it's not going to be in there. There's another 22 cars, so altogether that's now 28. So we've got 28 cars so far lined up. So if you'd arranged the first 28 speeds, they would only go up to and including 20 miles per hour. So here is the 120.5th value in these two categories? No, it's not. Now we've got another 90 cars. Well, 28 plus 90 would be 118. Now we're looking for the 120.5th. Well, that's not enough cars, so the 120.5th car wouldn't be in this category. Now we've got another 80, so if we add on another 80, that'd be 198 cars. Now the 120.5th one would be in this category, so the 120.5th car would be in this category. So the answer would be 30 is less than x, which is less than or equal to 40. So this is the class interval that contains the median. So that's one approach. So one approach is to take the grand total, add 1, divide it by 2, and that tells you the position of the median. Okay? The other approach is the same, where we add up to see how many there are all together. So that's 240. And then what we do is, rather than adding 1, because here we've got group data and we don't know the speeds anyway, we've got 6 cars that are between 0 and 10, 22 cars between 10 and 20, we don't know the actual speeds anyway, and this is quite a large number, so the effect of adding 1 doesn't actually make much of a difference in this case. We can just take our 240, and rather than add 1, we can just divide it by 2, and that would be the 120th value. And because this is group data anyway, we don't know the actual numbers, we can just divide it by 2, and it gives us roughly where the median would be. So is the median in here? No. We're looking for the 120th one? No. Is the median in here the 120th one? No, that's only 28 so far. We've then got another 90, so that's another 90, so that'll be 118. So is the 120th one in here? No. We've now got another 80 speeds, so that'll be 198. Is the 120th one in here? Yes, it would be. So again, the class interval that contains the median would be x is bigger than 30, but less than or equal to 40. And either one of these two approaches would work. Typically, whenever you're asked a question, they would make it so that the class interval would be the same using either approach, but just make sure you show your method whenever you're doing it. Okay, part B. Part B says draw a frequency polygon for the information in the table. So if we go back up to the table, we've got the speed between 0 and 10 miles per hour. There's 6, so we want to go 5 across and 6 up. So let's do that. So now we're going from 0 to 20. So if we in 10 squares, so 20 divided by 10 is 2. So we're going up in 2s here. And we're going 5 across and 6 up. So 5 across and 6 up would be 2, 4, 6. So that'd be the third little square up. Next, we've got between 10 and 20, there's 22, so that'd be 15 across and 22 up, so 15 across, there's 20, so 22 would be one little square above it, 22. Next, we've got between 20 and 30, so we're going to go 25 across and 90 up, so 25 across and 90 up would be there. Then next, we've got between 30 and 40, so we're going to go 35 across and 80 up, so 35 across and 80 up would be there. And finally, between 40 and 50, so we're going to go 45 across and 42 up. So 45 across, up to 40. We want to go to 42, so that's just one more little box, that'll be there. And then if we just join up our points with a ruler and pencil, then that'll be our frequency polygon done. So it's there to there, there to there, there to there, and there to there. And that's it. So we've drawn our frequency polygon. Okay, let's have a look at our next question. So our next question says, the table shows the information about the heights of 152 people. So we've got their heights, so between 0 and 120 centimetres, between 120 and 140 and so on. And we've got the frequencies. And Zoe draws a frequency polygon for the information in the table. So she's drawn this frequency polygon. And the question asks us to write down 2 mistakes that Zoe has made. So she's made 2 mistakes when she's drawn that frequency polygon, and we're to say what they are. So let's have a look at it. So if we have a look at this frequency polygon, well, it starts here at 120 and up to 5. It goes up to 140, up to 40, and so on. Now the first point was at 120. If we have a look at our first point, we've got it should be in between 100 and 120. So I'd actually plot it at 110 and up to 5. Now Zoe's plotted it at 120, not 110. Actually, does she carry on this for all of them? Let's have a look and see. So I would plot 130, 150, 170, 190. But Zoe's actually plotted each of the points at the end of the category. She's not plotted them at the middle of the category. So she, instead of plotting it at 110 and 130, she's plotted at 120 and 140. So that's the first mistake. So I've just written that Zoe should plot all the points at the midpoint of each class interval. So she hasn't done that. Okay, let's have a look at her mistake 2. So she has drawn the axes and she's got frequency and height. That's fantastic. The scales look okay. They're going 0, 10, 20, 30, 40, 50. So and then horizontally 100, 120, 140 and so on. Yeah, looks okay. Let's look at the frequencies. Oh wait, we've got here 30. But if we look here, this point has got a frequency of 40, the second point. If we look, the first one had a height of 5, frequency of 5, that's great. The second one, 43, that's okay. 49, that's okay. 25, that's okay. It's this point here, the second point should have had a height of frequency of 30, not 40. So I'd write that down as well. And that's it, so just the second point should have a frequency of 30. She plotted at 40. Okay, let's have a look at our next question. So our next question says, the table below shows information about donations 62 people made a charity. So we've got their donations, so 7 people made a donation between 0 and £5, 20 people between £5 and £10, and so on. And Humphrey drew a frequency polygon to show the information. Whoa, okay, and here's this frequency polygon, and we've got to write down 2 mistakes that Humphrey has made. Well, first of all, he shouldn't have joined up the first point and the last point. That shouldn't have been joined up. He should have just actually drawn it like so. So that's a mistake. Okay, and the second mistake, well, actually, if we have a look, he hasn't labelled his axes. We've got here the donations between 0 and £25. Is it 0 and £25? Yeah, it is. But he hasn't labelled his axes. He hasn't written down here donation. And he hasn't written frequency, and that's very important, writing frequency on the vertical axis. So he hasn't labelled his axes. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at question number 11. So question number 11 says the frequency polygon shows the length of 330 river eels. So here we've got 330 river eels, and there's their lengths, and you've got the frequencies vertically and the length horizontally. And the table below show the lengths of 330 sea eels. And part A says draw the frequency polygon of this information on the diagram above. So between 0 and 20, we'll plot it at 10. We're going to have a frequency of 12. So we're going to go at 10, we're going to go up to 12. Now let's just check, we've got, there's 20, and it's 1, 2, 3, 4, 5. So if we do 20 divided by 5, that means we're going up in 4s here. So we want to go up to 12, so that's going to be 4, 8, 12. That's going to be the third little box there, 12. Okay, our next point is going to be plotted 30 across 60 up. So 30 across and 60 up would be there. Our next point would be 50 across and 108 up. So 50 across 108, well, there's 100, 104 and 108 would be there. So 2 up there because you're going up in 4s, 104, 108. Our next point would be 70 across and 90 up. So 70 across and 90 up. So that's going to be halfway between 80 and 100, so in the middle here. And then finally, our last one, between 80 and 100 centimeters, the frequency is 60. So we're going to go 90 across and 60 up. So 90 across and 60 up would be there. That actually looks as if those sea eels are slightly longer. So if we join them up with ruler and pencil, so joining up the first point, the second point and the third point, the third point and the fourth point, and the fourth point and the last point. And that's it. Okay, let's have a look at our next question. Part B. Part B says calculate an estimate of the mean length of the sea eel. So we want to find the estimated mean. Now this is quite nice actually, because Rather than just giving us the frequency polygon, it says the mean length of the C eel. We've got the frequency table for it. We've got actually the group frequency table for it. So we can work out an estimate of the mean from this, okay? And if you need any extra help on the estimate of the mean, I think it's video 55 on Corbettmaths is the estimated mean video. Okay, so let's find the estimate of the mean. So what we're going to do is, remember, to get the mean, we want to get the grand total and divide by the total frequency. Now what's great is in this question, we're told the total frequency is 330. So that's great, we don't need to add up the frequencies. Okay, now we need to find the total length of the eel. So if you line them all up, what would they be? Now the question is an estimate because we don't actually know the length of these 12 eels. We just know that these 12 eels have got a length between 0 and 20 centimeters. So we're going to let them all have a length of 10 centimeters. It's the fairest number to choose between 0 and 20. We're going to let them all have a length of 10 centimeters. Between 20 and 40 centimeters, we're going to pretend these 60 eels all have a length of 30 centimeters. Between 40 and 60, we're going to let these 108 eels each have a length of 50 centimeters, and so on, 70 and 90. So that's the midpoints. Now what we're going to do is we're going to multiply 12 by 10, because if we send this 12 eels and they've each got a length of 10 centimeters, 12 times 10 is 120. So what we're going to say is that's going to be our estimate to how long those 12 eels are. Now I'm going to add on a column, it's called the FX column, and that's what we get when we times the frequency by the midpoints. So 12 times 10 is equal to 120, so 12 times 10. 60 multiplied by 30 is equal to 1,800. 108 times 50, so 108 times 50 is equal to 5,400. So 90 times 70 is equal to 6,300. And the midpoint times the frequency here, so 90 multiplied by 60, 90 multiplied by 60 is equal to 5,400 again. Now what we're going to do is add those up to get the total length of the eels, our estimate for the total length of the eels, so 120 plus 1,800 plus 5,400 plus 6,300 plus 5,400, and that's equal to 19,020. And then if we divide the total by the total frequency, that'll give our estimate of the mean length of each sea eel. So 19,020 divided by 330 is equal to 57.636363 and so on centimeters. And let's just round our answer to 2 decimal places. So let's call it 57.64 centimeters to 2 decimal places, to 2 decimal decimal places. And that's it. Okay, let's have a look at our next question. So our next question says the frequency table shows information about the weights of some rugby players. So we've got some rugby players, so between 50 kilos and 60 kilos, there's 14 players. Between 60 and 70, there's 22 players. 50 players have got a weight between 70 and 80 kilos, and so on, kilograms, and so on. And part A says draw a frequency polygon to represent this data. So we're going to go 55 across and up to 14, 65 across and up to 22, 75 across and up to 50, 85 across and up to 64, and 95 across and up to 20, and then join those up. So let's do that. So we're going to go 55 across and up to 14. So 55 across. Now we're going between 0 and 10. There's 5 little boxes. 10 divided by 5 is 2. So we're going up in 2s here. So 55 across, and we're going up to 14. So 55 across is in the middle of 50 and 60 there. So it's 10, 12, 14. So that would be there. Let's put a point there. Next, between 60 and 70, so 65 and 22 up. So 65 is 20, 22 will be the next one up. Next, so we're going to go 75 across and 50 up. So 75 across and up to 50. Between 80 and 90, the 64 players with a weight between 80 and 90 kilograms. So we're going to go 85 across and up to 64. So 85 across and up to 64. So 60, 62, 64. And then finally, our last category, between 90 and 100 kilograms is 20 players. So between 90 and 100, we've got 20. And then what we're going to do is we're going to get a ruler and pencil and join those up. So put the first point to the second to the third to the fourth, and the fourth to the fifth. And that's our frequency polygon. Okay, part B. Part B says write down the modal class interval. So if we go to our frequency polygon, we can find where the peak is, the highest point, and that would tell us the modal class interval. So in this case, it'll be between 80 and 90. Alternatively, I probably would just go up to the table and look which one has the highest frequency. So as you can see here, 64 is the highest frequency. So the modal class interval would be that. So let's write that down. So the weight is bigger than 80 kilograms but less than or equal to 90 kilograms. Okay, next part. One player is chosen at random. So a player is chosen at random. Now in this question, we're not told how many rugby players there were altogether, so let's add them up and see how many there were, because we're going to need that for the probability. So 14 plus 22 plus 50 plus 64 plus 20. That's equal to 170. So there's 170 rugby players. And the question says, work out the probability that the player has a weight that is more than 90 kilograms. So there's 170 players, and we need to figure out how many have got a weight more than 90 kilograms. So if we look at the table, more than 90 kilograms, well, there's 20 players that have got a weight more than 90 kilograms. So it's going to be 20 out of 170. And if we cancel that down, divide both of those by 10, we get 2/17. So the probability that the player who's got a weight more than 90 kilograms is 2/17. And that's it. So question number 13 says the frequency polygon shows the weights of 120 red apples from an orchard. So we've got the weights of these red apples, 120 red apples, and it's been drawn on a frequency polygon for us. And then the table shows the weights of 120 green apples from the same orchard. So we've got the weights in grams, so the weights between 0 and 50 grams. So there's 4 green apples with a weight between 0 and 50 grams, 12 between 50 and 100, and so on. And we're told to draw a frequency polygon to show this information on the diagram above. So we need to draw a frequency polygon for the green apples. So these are for the red apples, so these are for the red apples, and we're going to draw the same for the green apples. So first of all, we've got between 0 and 50, and there's 4 apples there. So between 0 and 50, we're going to plot a 25 across and up to 4. So let's go to 25 across there and up to 4. Now from 0 to 10, there's 10 little boxes, so we're going up in 1, so we just need to go up to the 4th little box there. Okay, next, between 50 and 100, we're going to go up to 12. So that's 75 across and up to 12. So 75 across and up to 12, so it's 10, 11, 12. So it's going to be there. And next, between 100 and 150, so we're going to go up to 125, and then that's going to be up to 40. So we're going to go across to 125 and up to 40. So it's 125 across and up to 40 would be there. Next, we've got between 150 and 200, so we're going to go 175 across and up to 48. So 175 across and up to 48 would be there. And finally, between 200 and 250, there's 16 apples. So we're going to go 225 across and up to 16. So 225 across and up to 16. So 10, 15, 16 would be there. And let's join our points up. And that's it. So you can actually see that the green apples in this particular orchard have got a heavier mass, or they weigh more than the red apples. Okay, let's look at our next part. Part B says compare the two distributions. Well, we can actually see if we look at these frequency polygons, the frequency polygon for the red apples is further to the left. And in terms of the weights or the mass of the apples, that means they're closer to 0. Whereas the green apples, their frequency polygon, the distribution is further to the right. That means that they're going to have heavier apples. They've got a higher or greater weight or mass. So they're further to the right. So that's what I'd probably write down. So let's write that down. And that's it. So just written, the green apples have a distribution that is further to the right, so they are heavier than the red apples. And that's it. Okay, question number 14. So question number 14 says the frequency polygon shows information about how long people spend in a swimming pool. So this is information about how long they spend in a swimming pool. We've got time along the bottom, so between 0 and 100 minutes. And we've got the frequencies going up vertically from 0 up to 25. And we're asked to calculate an estimate for the mean time spent in the swimming pool. So in this question, we haven't been given a table. So what we're going to do is actually we're going to create our own frequency table. So let's write down time and frequency. And let's look at our points. So the first point is plotted in between 0 and 20. The second point is plotted between 20 and 40. The third point is plotted between 40 and 60. So what we're going to do is we're going to write those class intervals down. So we're going to say the time is between 0 and 20 minutes. We're going to then say between 20 and 40 minutes, between 40 and 60 minutes, between 60 and 80 minutes, and between 80 and 100 minutes. So there's our class intervals, because each of those points is in between 0 and 20, 20 and 40, 40 and 60, 60 and 80, and 80 and 100. Now let's look at our frequencies. Now we're going from 0 up to 5, and we're doing that in 10 little boxes. So if we do 5 divided by 10, that's 0.5. So it means that 2 little boxes is 1. Okay, so we're going to go up 2 boxes, that's 1, up and over 2 boxes, that's 2, up and over 2, 3, up and over 2, 4, and up and over 2, 5. Fantastic. So the first frequency is 5, the second is 20, the third is 15. Let's put those down. 5, 20, and 15. And the last two frequencies are 25 and then 1, because 2 little boxes is 1. So 25 and 1. So 25 and 1. Now we're working on an estimate of the mean because remember we don't actually know the amount of times that each person spent in the swimming pool. So what we're going to do is we're going to add on two columns, the midpoint and the fx column. So midpoint and fx. Now this time I'm adding on in a midpoint column. Previously I just wrote the midpoints beside them, so you don't actually need to write the midpoint column on as long as you write the midpoint somewhere. But I'm going to write the midpoint column down. So between 0 and 20 minutes, well, let's pretend they each spent 10 minutes in the pool. Between 20 and 40, let's pretend they spent 30 minutes in the pool. Between 40 and 60, let's pretend they spent 50 minutes each in the pool. We don't actually know, remember. Between 60 and 80, 70 minutes, and between 80 and 100 minutes, that's 90 minutes. And then fx, because it's 5 people that each spent roughly 10 minutes in the pool, times them together, and then that will give us our estimate for how long these 5 people spent in the pool in total. 5 times 10 is 50, 20 times 30 is 600, 15 times 50 is equal to 750, 25 times 70, so 25 times 70 is equal to 1750, and 1 times 90 is equal to 90. And if we add up the fx column, that will give our estimate for the grand total amount of time that these people spent in the pool, and that is equal to 3,240 minutes. And in the question, we're not told how many people. Sometimes we're told that. We will need to add up the frequency column here. So we need to add up the frequency column. So that's going to be 5 plus 20 plus 15 plus 25 plus 1. That's equal to 66 people. And if we divide the grand total, the 3,240 by 66, that's our estimate for how long each person spent in the pool, or our estimate of the mean time spent in the pool. And that's equal to 49.0909 and so on minutes, or let's round it to one decimal place, 49.1 minutes to one decimal place to 1 dp. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on Frequency Polygons. I really hope you found this video useful. And if you have found it useful, please like it and subscribe to the YouTube channel. If you do need any extra help on Frequency Polygons, feel free to watch videos 155, 156 on Corbettmaths. But again, I really hope you found this video useful. If you have found it useful, please like it, please subscribe to the YouTube channel, and thanks so much. Cheers. Bye.